Okay, so today I want to look at a couple of things and figure out how to get things off my computer here. What we want to do is we want to look at the Venn diagrams using the traditional square of opposition and understand some principles. So let me give you a couple of things first. The first thing we have to remember is that there's two conditions. We're going to be looking at universal statements, A and E, and we're going to be learning that the circle represents a class that is known to have existence. So I and O statements are going to tell us about existence. Okay, so keep that in mind, and let's kind of talk about how these work. So there's four types of the diagrams that we've talked about, and so let's just make them real easy, real simple. We'll start here with an A statement, and in an A statement we have all A are B, and so in that case we shade this. In an E statement we have no A or B, and we would shade the football. In an I statement we would have some, oops, I goofed there, didn't I? Let's see if I can make this all work. Oh, isn't that slicker and snot? Alright, in an I statement we have some A or B, and in an O statement we would have some A or not B. Okay, so if we keep those in mind, that's the basis of how we would look at this idea. So let's think about some examples. And we're going to move over to the second page over here, if I can figure out how to do that. I'm going to move over to the second page, and we're going to look at an A statement. And that A statement is going to say that all unicorns are one-horned animals. So all unicorns are one-horned animals. So we have a unicorn as our subject, one-horned animal as our predicate. And we would write that as all unicorns are one-horned animals. Okay? So that's an easy way for us to look at that. Now, if we're doing Aristotelian, we're going to say, okay, now the question is, we're looking at, do they exist? So we could look at it and say, this point right here tells us that unicorns are one-horned animals and they would exist. If they existed, we would put a circle X here. But we do not have proof that unicorns exist, therefore we're going to leave this blank. Let's take, for instance, this A statement. Let's say that all dogs are mammals. Okay, so this one's a little bit easier for us to look at. So we're still going to diagram it the same. And we're going to say all dogs are mammals, and so we're going to look at it from a Boolean standpoint. We would say that all dogs are mammals, all these dogs are mammals. Okay, but in a traditional Aristotelian standpoint, what we'd have to do is say these are the dogs that represent mammals because they're incorporated in the mammal circle. Therefore, what we would do is we would put a circle X here to identify the existence of dogs in the mammal arena. If we looked at an E statement and we said no space aliens, so we're going to say aliens, oops, so no aliens, hang on a second, I'm working on this, so no aliens, why it's doing that, I don't know, so no aliens are space creatures. So we're going to put the S here. And so if we were to diagram that, what we would do is that we would fill this in, right? So we fill in our football. That represents that no A's are S's, right? But the question is, we know that aliens do not exist, okay? Or we would say we're pretty sure they don't exist. But we know that sea creatures do. We've seen them, and we've seen these huge, obviously whales, and we've seen these big eels that have washed up on the coast of California, other things like that. And so what we could do is we could say that sea creatures exist, therefore we would put an X circle X right there. Okay, now another E statement that we could look at would be, we would say that no cats are sea creatures. So we would shade that as normal. Now, do cats exist? Absolutely. Therefore, we put a circle X. Do sea creatures exist? Absolutely. Therefore, we put a circle S. So what you've seen, what we've done is, what we've actually done is we've identified, in these cases, we've identified existence. So in this case, we know that cats exist, and we know that sea creatures exist in our fourth circle, our fourth diagram on page 2. Okay, so let's look at a couple of things. From an Aristotelian standpoint, okay, so from an Aristotelian standpoint, let me make sure I have everything in order here. From an Aristotelian standpoint, what we would have is we say A is true. Oops, it's not working for me at the moment. A is true. Therefore, that would mean that I would be true. You know, it's really hard to begin to learn how to use these. How's that? True. Okay, so you're experimenting with me, so we're having a little bit of fun here, I hope. Okay, so A is true, therefore I would be true. Okay, we can also, using the Aristotelian square of opposition, say that if A is true, and we know that true comes down from above, that I is true, right? So we can see that from there. We can go from universal to particular in anything that we do when it comes to proving existence and dealing with Aristotelian. But there's one rule that we have to keep in mind the entire time, and that is we can only go from universal to particular, and we can only do it within the same quality. Okay, so I can only go universal affirmative to particular affirmative. I can only go from universal negative to particular negative. I cannot go the other direction. The other thing we have to remember is that universal, in Aristotelian, the universal will always be the premise, and the conclusion could be a universal, but it could also be a particular. And that's because the conclusion is more defined than the premise, and therefore the premise could be an all, where the conclusion would be a sum. So keep those things in mind. Hopefully this helps a little bit. We'll go over more in class. If you have questions, bring them to the class. I'll keep working on this little pen tablet, and maybe by the time I do this the next time, I'll be a little bit more effective in my approach. Hopefully, though, the illustration was helpful to help you see what's going on and just not hear what's going on. If you have questions, write them down, bring them to class. We will see you then.